Okay, so let's start with the Sudoku problem. So I hope you guys know what is Sudoku. Sudoku is like we have a matrix of n by n, and you have to place a number from 1 to n, and those numbers should be not repeated in a particular row or column or a particular submatrix, right? So for example, if you'll see here, this 0 will try to fill with any of the number between 1 to 9 because it's 9 by 9 matrix. So if we put 1 here, so this row's condition is satisfied, right? We don't have any duplicate 1 here. We don't have any duplicate 1 in the column. Along with it, we also have to check the submatrix. If the submatrix has any duplicate 1 or not. If it doesn't have, means this can lead us to one of the solution, right? So what we are going to do is basically use backtracking here to see, like, what is the final solution we have. So okay, so that's how backtracking works actually, right? So you have a plan A, you go with the plan A, and in between or at the last of the solution, you find out, okay, this plan is not working. So let's go back and start again, right? So suppose, like, okay, so the for this 0, suppose you are keeping 2 here. So if you'll see, okay, 2 is fine here in the row, 2 is fine here in the column because it doesn't have any duplicate. 2 is also fine here in the matrix, this submatrix, right? So this can lead us to a solution, a good solution, right? Now let's try 8 here, okay? So when we are putting 8 here, we can see the row is fine, right? Let's see if we are good with column also. No, we are not good with the column because it has already a 1 8 in the column, so we cannot keep 8 here. So what we'll do in this condition, we'll backtrack. We'll go back to the previous state and we'll try some other value. So let's try with 9 now, right? So 9, if you'll see, we are good with 9 here, okay, or with row. We good with column also. Yes, we are good with column also. Now we'll see if we are good with some matrix also. Yeah, we are good, right? So this can lead us to one of the solutions. So that's how we are going to approach. We are basically try different numbers and see, like, if it is leading us to the correct solution or not. Okay, and if it is not leading us to the correct solution, we have to track back and try for the plan B, means another number, right? Okay, so let's go back to the previous state, and yeah. Okay, yeah, this is the solution. So backtrack, we are going to use backtracking for this, which I have already explained in the previous problem, nquin problem. So it's not a rocket science. It's just like hit and trial thing, kind of. That's what I believe. Okay, so we are going to code it in Java. Okay, we are going to create a project here. Next, and yeah, Sudoku, uh, Sudoku solution. Okay, finish this terminal. We are going to create a class file here. Sudoku. So okay, okay. Now what we are going to do is main method, right? And in that main method, basically we are going to create the matrix. Mm, matrix is equal to new matrix, and I've already copied some value here. Okay, so yeah, so this is our matrix that which we are going to work. It's same as this value that I have already copied because it was taking a lot of time, so I prepared it in advance. Now we are going to solve this. So how we are going to solve this? We are going to basically create a method, public static solve Sudoku, which is going to take obviously the matrix and uh, the size, right? Size of the matrix, and it will return us Boolean. Okay, so this is basically going to tell us if we have a solution or not, right? Now, what we have to do, we have to solve this matrix, right? Hmm. Yeah. So basically, what we have to do, we have to loop through the matrix and find where is the uh, zero, because for that we have to find the solution, right? Wow. And this is and check if what value can be submitted there, right? So if uh, matrix of I j is double equal to 0, means if we have a 0, then we have to find a number which is going to which is going to lead us to a correct solution, right? So what we'll do, we'll store that particular index. Okay, so to store the index, we'll create a variable here. Right? Row index is equal to I, column index is equal to j, right? And if it is found, if a 0 is found, basically we are going to break here, and this break will take us to this for loop, out of this for loop. And now if, yeah, row index, oh, okay, how to identify if it has found a 0. So we'll do one thing, we'll keep it as -1, we'll keep it as -1, okay, or any number which is not between 0 to any positive integer is not equal to -1, means we have found a 0, right? Yeah. So if we have found a 0, we have to break, we have to go out of this loop, then break, right? So this will come out of this for loop. Now, along with it, if it has reached to the final, right? If I is double equal to n, and okay, so this I we need to declare outside so that this value will persist, and we'll have the condition where we have to where condition where we have to identify, okay, we have reached to the final solution or not. J is equal to 0, right? If I is double equal to n and j is double equal to n, then we have to return true, means we have, dude, true. So why this condition? Because okay, if we'll go here, this, if we have we have found solution for all these cells, and we have come to the last, and we have found a solution for this also, means like we have reached to the final solution, right? So that's what I'm checking here. If it has reached to the final solution, I is equal to n and j is equal to n, means we have reached to the last index of the matrix and we have the solution, right? So we have simply have to return. Else, if this is not the case, then what we have to do, we have to no, assign a number. So for I, k, okay, k is not looking good, so we'll take it as value. Okay, is less than 9 or less than 10. Okay, because we have to put the value from 1 to 10. You know, what we have to do. Okay, so we are here. We have to check if assigning a particular value to a particular cell means this thing. If we are assigning one here, if it is safe to keep one here or not, right? So we'll create a method actually. So if is safe, we'll basically create a method which will basically check if the value that we're keeping there is safe to place or not. Value, comma, mm, row index, comma, column index, comma, size of the matrix, right? So we should, one thing we should always keep in mind to not take a spaces between the variables and whatever we are writing, so that the code will look good and it will be more visible. If it is safe, okay, we'll write that method later. First we'll check like if it is safe to keep that value or not, right? So we have checked if it is safe to keep or not. If it is safe, then what we are going to do, okay, so we are going to assign that value to the matrix. It's equal to value, right? And then we are going to call um, for the next index, right? So recursively we'll call the same method, this method, right? Okay, so okay, what we can do here, we can basically put it in if condition. If this solution is leading us, not leading us actually, if because this particular method returns true or false, right? So if this particular solution is not leading us to to a value, to sorry, to the final solution, then uh, what we'll do, we'll simply assign, sorry, if this is not leading us to any solution, then we'll track back and we will assign it to back to 0, right? And if it is giving us the solution, then we have to say that okay, we have found the solution, so we have to return true, right? That's it. We are good, right? That's it, I guess. That's the logic. Now, okay. The one thing that we are missing is like, okay, suppose you didn't find anything to place, like from 1 to 10, right? Okay, this value should be 1 actually. Sorry. So between 1 to 9, you didn't find any value which is satisfying this all three constraints. So what is was that? What does that mean? It's mean that you have chosen some wrong numbers here, or maybe here, or maybe here. You have chosen some wrong number which is not leading you to the correct answer. So basically what we have to do in that case, if you have come to the last of trying all the values, then basically you have to return that okay, this is not the correct solution. So you have to return false so that it will try for the next number. Okay, so we are good here. Good here, good here. Okay. Now we'll write the safe method. Is safe method. Public static boolean is safe. Okay. What does it take? It takes integer matrix, right? Comma value, comma int row index, comma and call index, comma. Okay, size of the matrix, right? That's all we need, I guess, right? Okay, so yeah, so basically what we have to do, we have to check for the safety. So row, and column, and this matrix, right? So we'll go for it. So first we'll do row check, then column check, right? And then submatrix check. Go for row check. So row check, I think it's easy. I so okay, just keep it as J because J will be moving, right? Because column this so when we are checking row, so basically the column value will move and row value will be fixed here, right? So yeah, if um, matrix of a row index and j is sorry is double equal to value, means we have to check if it already has a value, then we have to return false. That's it for the row. Similarly, we'll keep this as I. It doesn't matter, but just for clarity, because generally we assume I is a row and j is a column, right? So yeah, so I, and this will be column. Column will be fixed here, right? So when we are checking the column by column row, basically, so this row value will be moving here, and j value will be fixed, right? So yeah, column value will be fixed, and row will be basically moving. So yeah, and submatrix. Now we have to check submatrix. How to check submatrix? So to check the submatrix, okay, let's take an example of this one. So its value will be 0, 1, 2, 3, 4, right? The column value will be 4, row value will be 0, right? Yeah, so if you want to consider this matrix, basically what you can do, okay, modulo. Okay, if you do the modulo division of this is 3 and this is 4, right? 4 modulo division 3 will basically give you 1, right? And if you 1, so means like 1th, first, 0th submatrix and one first submatrix, right? So basically if you'll so how to identify it, right? So what this will be the starting index of it, right? So yeah. Hmm. Okay, got it. So uh, row index. So this basically we want this index, right? For this to be the starting index. So 4 modular division 3 is equal to 1. And if you like 4 minus 1 is 3, right? Yeah, this one. Got it. So basically we'll declare a variable here, row int row base row base row index is equal to uh, row index minus row index modulo division 3. Similarly, int sorry base index is equal to column index minus mm, column index modulo division 3. We have it, right? So we'll write two for loops and we are good. This will be base row index for that particular submatrix, which you have to go to till base row index plus 3, right? And then again for j, when j will be nothing but base column index and it will be less than base column index plus 3, right? And then the same thing, if matrix of I comma j is double equal to 1, sorry, no, the value basically return false because that submatrix has duplicate value, right? We could here, yeah, if nothing satisfy then we are good, right? Sorry, if nothing fails in all of these checks then we are good, right? So true. That's it, guys. I think it's fine. PR checking is safe here, and then we have this matrix. We are getting row index and column index here, whichever has 0, right? And then if it has reached to the final solution, then we are reading final index. Then we are returning true because we have the solution. If it has not reached there, so what we are doing, we are basically checking it is safe to put it there or not. If it is not safe to put it there, if it's safe to put it there, we are assigning the value. Otherwise, so yeah, otherwise, yeah, if it is safe, then we are returning false here. No, if it is not safe, we are returning false here. Now, if it is safe to put the value here, we are trying for the next value, right? Next 0, where we can keep some value. And if this assumption is not leading us to a good solution, a final solution, we are track backing and assigning it back to the previous state, and if it is leading us to the solution, we are simply returning true. Hmm, that's it. Now we have to call it also. Okay, so if solve Sudoku matrix comma 9, because it's 9 by 9 matrix. If it is giving us a solution, then we have to print it, right? For I, yeah, that's it. Let's run it and see. Again, same issue, man. We'll print it in a better way again. So after this, for sort, I think this will do. Yeah, so we have a solution, right? It's correct only. One so satisfied, this is satisfied. Let's check if this one is satisfied. Yeah, this one is also satisfied. This window particular, you can see this, it doesn't have any 9. This 2 is also looking good. Yeah, I think we're good. So this is a solution. So it's nothing, it's quite easy. But what all we have to do is find a solution using backtracking. So basically we are finding, no, here we are finding the particular value that has particular index that has 0, because we have to replace all the zeros with some numbers between 1 to 9. As soon as we are finding that number, basically we are going out of this loop, and we are checking if we have reached the final solution, final index or not. If we have reached, it means we are good to display the Sudoku, and we have the solution. If it is not, then uh, yeah, if it is not, then we are basically going and checking for assigning a particular index of value, right? And we then after assigning, we are checking if it is safe to place that value there or not. If it is safe, then we are assigning that value, and we are calling for the next element, for the next cell, to find the solution for the next cell. If solution is giving us true, means we are returning true. If it is not giving us a solution, so we are no backtracking and assigning the previous assumption as 0, because whatever we assume that it's leading to us to a correct solution is not actually a correct solution. So we are putting it back to the previous state, right? And if there is no solution, there is no number which is possible to put on that particular index, we are returning false here, right? So that it can go to the previous index, and it can try for the new value. And in is safe, we are basically checking row here, we are basically checking column here, and then we are checking the submatrix here. This is a bit tricky. You have to basically find the index, right? So row index and column index, and what is the submatrix, starting submatrix indexes for these particular row index and column index. uh, yeah guys, I think we are good. So if you like this, please share, subscribe, like this video, share with your friends. Okay, thanks for watching this. Have a good day.